Alright guys, we're here with Brian and he's sitting in the Biodex, which is going to measure his torque or his angular force that he's going to be able to generate using his bicep. So we have him hooked up to EMG and we've got an electrode sitting on his bicep and a ground to make all the electrical impulses kind of level out so there's no noise. And so it's going to put all that into the computer and overlay it with the torque that he's going to be able to generate. And we're going to run through a couple different testing scenarios, and then I will be putting the graphs and kind of explaining those in future videos for you guys to watch as well. So we're going to start off doing the force-length relationship. So we're going to test his ability to generate torque at 3 different lengths. That's going to be short, optimal, and long. And so right now we have him set up at the long setting, and we're going to see what kind of force he can generate in an isometric or stationary position. So go ahead and click
and go.
So we're going to get him to test for just a second or two and then measure his maximal torque value, and then we'll record that and then move on to the short and the optimal lengths. Alright, so we're back and we're going to be looking at the optimal length, and so that's around 90 degrees of elbow flexion. And what the optimal length essentially is saying is that he should be able to generate the most force here because of the appropriate actin and myosin cross-bridge overlap. So because everything is in like the Goldilocks zone, he should be able to generate a higher force than both short and long lengths of the muscle. So go ahead and give it a go.
And go.
Alright, so for the last bit of the force-length relationship, we're going to look at the short length. So ideally he's going to generate a less torque than the optimal, and in some cases less than the long. It kind of depends on the short and long what type of torque the person will generate. So go ahead.
And go.
So now we're going to be looking at the force velocity curve. So we're going to start him at the eccentric side, which is going to be the negative side of the graph. And we're starting out at negative 180. So he's going to be concentrically flexing his bicep at 180 degrees per second. And then the machine is going to load him eccentrically and force him down at 180 degrees per second while he's fighting it. And we're going to look at both the torque and the EMG for both of these as well. So.
And go.
Alright, so again for the force length velocity, we've slowed down the velocity of the machine to 120 degrees per second. So he'll probably generate a little bit lower torque here. So we'll go ahead and take a look at this one.
And go.
So now for the last velocity in the force velocity curve, we're looking at 60 degrees per second eccentrically, so it's going to be even slower. So he'll probably generate a little bit lower torque even here than he did before.
And go.
So now we're going to be on the positive side of the force velocity curve. So he's going to be concentrically flexing his elbow and then concentrically using his tricep to extend the bar back down. But we're only going to be looking at the bicep side and looking at the torques that he generates at these velocities as well. So we started out at 60 degrees per second. So go ahead with this one.
Go.
So now we set the machine to 120 degrees per second and concentric. So it's going to be the same thing that we're on the positive side of the force velocity curve. So go ahead with this one.
And go.
So now for the last bit of the force velocity curve, we're looking at 180 degrees per second, and that's going to be, again, concentric. So it's going to be on the right side or the positive side of the graph. So go ahead.
And go.